Alright guys, welcome to our channel. For those who are new, please subscribe for more content. So I am Mark and this is the Hoodie tutorial. And this time we're going to talk about series parallel and parallel series circuits, also under DC circuits. So right here we have a series parallel circuit. So the reason why it is called series parallel circuit is that we have a series resistor right here. Right, this is in series without this one, so we have R1 and R2, and then we have a parallel resistors right here, which is R2 and R3. On the other hand, we have here a parallel series circuit. So just like in this circuit, we have a parallel circuit. This is right here, we have three parallel circuit because these are has two branches of wires, and then the current or the total current will split up into two branches, and then we have a series resistor right here. So that's just a basic definition of these circuits. So another definition for the series parallel circuit is that when you try to simplify it, is that it will come up to a series circuit only, because when you try to unify this parallel resistor right here, we could have a total resistor for this two, which will come up into only two resistor which is connected in series. Another one is that the reason why this circuit is called parallel series circuit is that when you try to simplify it, is that we will come up into a parallel circuit, because when you try to find the total resistance of these two resistors that are connected in series, you will come up with only two resistor that is now connected in parallel. So that's it for just the definition. Let's go to finding the total resistance. So how about in this one? In terms of finding the total resistance of this series parallel circuit, the only thing that you need to know is that first thing we have to look up right here. Now this is in parallel circuit, R2 and R3. We can simplify this. So basically that's just equals to 1 over, let's put it this way, 1 over R2 plus 1 over R3, since this is connected in parallel, and then raise that into 1. And then when you try to simplify it, you will come up with only one resistor that will become series into R1. So therefore you can just add R1 right here. So therefore this would be our total resistance. So that's it for the series parallel. Let's go to parallel series. So first thing you have to look up in here, especially when your circuit only has a one DC source. So therefore this R2 and R3 are connected in series, so we can add that is R2 plus R3. And then when you have this total resistance for these two resistor connected in series, you will come up with only two resistors right here in the original circuit, which is connected now in parallel. So therefore you can put it this way, 1 over R2 plus R3, and then you can also add the 1 over R1, and then raise all that up into -1. So therefore this would be our total resistance. So when we try to find the total current right here for the series parallel is just equal to when you try to find the total current for the parallel series circuit, so that just equals to IT is equals to VT over RT. So Ohm's law. The same also with power, we can use PT is equals to IT squared, and then the total resistor or resistance, and then also we can also use this one, the VT multiplied by the total current. The same also with the parallel series circuits. We have IT is equals to VT when we already have RT, and then the PT also, or the power or the total power, is also equals to IT squared RT, or equal to the total voltage multiplied by the total current. So honestly, we could also have a combination of these two type of circuits. So when we have that combination of these two circuits, we will come up with a more complex couple of resistors connected in a combination of these two. However, the most important thing that you need to do is to find the total resistance first. And when you only have a one DC voltage source, you can always look up into its opposite direction in this one, and then trying to simplify it until you come up with the total resistance. So that's it for the series parallel and parallel series circuits. So let's go now to some of the examples to understand the topic even more further. Okay, so example number 1, we need to find the total resistance and the total current and also the total power. So we have here a DC voltage source which is 220 volts, and then we have a resistor right here, R1 100 ohms, and then R2 and R3 which are connected in parallel. R2 is 200 ohms and then R3 is 500 ohms. So let's find the RT first. So let's put solution right here. So when we try to find RT, RT is just equals to, let's put it just this way, and then we need to focus only in this thing first. So we have, since this is in parallel, we have R2 and R3, we can put it in this way. That is R2 plus 1 over R3 and then raised to -1. Substituting the value, that would become 1 over our R2 is 200 ohms, and then plus our R3 is 1 over 500 ohms, and then raise that into -1. So therefore that would become 142, that's 142.86 ohms. So therefore we can basically redraw the circuit. So right now we have, let's put redraw right here. We can also put it this way. We have a DC voltage source, and then we have a R1, and then since we already simplified the two resistors right here, we can now find the combination of the resistor, adding only up into 1. So we have a 220 volts, this is positive negative. Our R1 is 100 ohms, and our R2 will become this one because we already have simplified the two resistor. So therefore that is 142.86. So since we only have two resistors which are connected in series, we can now find that RT. So R1 plus this one, let's call that RT sub 1, or don't be confused, you can also substitute the direct value of this one. So that is RT is equals to our R1 is 100 ohms, and then plus our this one is 142.86 ohms. So adding that, we will have RT is equals to, that is 242.86 ohms. So therefore this is our total resistance for this circuit. So another thing is that we need to find the total current. Let's put it this way. IT is equals to, just use Ohm's law, VT over RT. So since we only have VT, which is 220 volts, divided by, since we only have RT also, that is 242.86 ohms. So therefore our IT is equal to, that is 0.91 amperes. So this would be our total current. How about our total power? So our total power is, we can either use this formula, IT squared times RT, or equal to VT times IT. So since we already have IT, or the total current and total resistance, we can use this one, and since we already have the total voltage and total current, we can also use this one. All of these either of this formula, we can have come up with the same value. So let's use this one. So our VT is 220 volts multiplied by our IT is 0.91 amperes. So therefore our total power is just equal to, that is 200.2 watts of power. So therefore this would be our total power. So that's it for example number 1. Let's go to example number 2. So this would be our example number 2. We need to find the total resistance, the total current, and the total power. So we have here a very complex circuit, but this is just so easy to solve. This is a combination of a series parallel and parallel series circuit. So I'm sorry, I forgot the put a value right here. So let's say this is a 13 ohms and this is 14 ohms. So first thing, we need to find RT. So let's put solution. So first thing is that we need to look at in this region. This is in series circuit, so we can just add up directly. That is 13 plus 14, that is equal to 27 ohms, and that 27 ohms will become parallel to this circuit, that will become 1 over 12 plus 1 over 27. Since 12 ohms and then 27 ohms are connected in parallel, we can use this one, that is equal to, that is 8.31 ohms. So since we already have this unified resistor value, this that will become only one resistor right here if you try to redraw, and then that resistor will become a series to these four resistors. So therefore we can add that would become 8 right here. These are all becoming a series circuit since we already simplified these three resistors into one, which has a value of 8.31. So therefore we can just add all that up. 8 ohms plus 9 ohms plus this one, 8.31 ohms, and then plus this 10 ohms, that is 10 ohms, and then also plus 11 ohms. So therefore that will become unified into only one resistor, which is equal to, that is 46.31. So we already have unified all of these resistors inside the circle. So therefore we only have a one resistor right here, which is of course in parallel to 6 ohms. So therefore we can add all that up also, that is 1 over 6 ohms plus this one, 1 over 46.31 ohms, which are connected in parallel. So therefore that would become, we have 5.31 ohms. So we already have simplified all these resistors inside the circle. So we are now having only one resistor, which is in turns being connected in series to these two resistors. So we can just add all that up so that we can come up with the total resistance. RT is just equals to, that is 5.31 ohms, and then plus, since these are in series in these two resistors, which is 5 ohms, and then plus this is this one, which is 7 ohms. So therefore our RT will become, that is 17.31 ohms. So therefore this would be our total resistance. So you can also use another method right here, which is a one line diagram, but for me this is a little bit more accessible ways in order to find the total resistance. So we already have the total resistance, we can now find the total current. So let's put IT is just equals to VT over RT. So our VT is 120 volts, that is 120 volts divided by our RT is 17.31 ohms. So therefore our IT, that is equal to, we have 6.93, this is 3 amperes. So this would be our total current. So right now we have the total resistance and total current. We can now find the power total. Let's just use this formula, VT times IT. So that is equals to 120 volts multiplied by our IT is 6.93 amperes. Our PT will become, that is 831.6 watts of total power. So we already have answered our total resistance, our total current, and our total power. So that would be for this video. I hope you learned something, and then if you have some question, please comment down below and I will try to answer it directly. By the way, you can actually get the notes for this tutorial. Just visit on the description down below and click all of those links, and then thank you so much again.